I think I am live now. Can anyone confirm if audio and everything is fine before we get started? Like, although I ended up solving all problem, but for the last problem, my solution was complete heuristic. So might not be the something which people might want to see as a solution of the last problem. Hello. Can anyone confirm if audio and everything is fine before we get started? Like, I did some changes with the mic, so it might be possible that something might not work correctly. Hello, hello. Sound okay? Thanks. Thanks, Raj. So let's get started with the first problem for the today. So first problem says exponential plant. Takashi is growing a plant. Its height at the time of germination is 0 centimeters. Consider the day of germination as day 0. Its height increases by 2 to the power I centimeter on day I is night for all I greater than equal to 0. Takashi's height is 8 centimeter. Every morning, Takashi measures his height against this plant. Find the first day such that plant's height is strictly greater than Takashi's height in the morning. So what the problem statement is asking us is, like, we have a plant which is initially, this is the land, and like we have some height of Takashi with us, which is given as h. And like on the first day, like on the 0 day night, the height of plant increases by 1. On the first day's night, the height of plant increases by 2. So overall height 3. On the third day, height increases by 4, and so on. It keeps on increasing exponentially, and it asks us to find the day when like the height of plant would be more than Takashi's height. So like a plant height would be somewhere like this. And the idea is like, since it's increasing exponentially, you can notice that on day 30, on the day 30th morning, the height of plant would be 2 to the power 0 plus 2 to the power 1 up to 2 to the power 29, and it is greater than equal to 10 to the power 9. So the answer is always less than 30. And to solve it out, we can brute force it over here. Like, we can keep increasing the height of plant every day and keep increasing the day until its height is more than Takashi's height. And essentially, that was my solution for this problem. So like I started with height of plant as 0, number of day as 0. As long as height of plant is less than equal to the height of Takashi, I increase like whatever height the plant will grow on today's night, and then I increase the day by 1. And at last, I print the day of morning which I am at, and essentially, this was the solution for this problem. I will move to the next problem. If there are any questions, I will come back to it after the next problem again. AtCoder Janken 2 and AtCoder users have gathered to play AtCoder RPS 2. The first user's name is SI and their rating is CI. The AtCoder RPS is played as follows. Assign the number 0 to and -1 to the user in lexicographical order of their usernames. Let T be the sum of ratings of n user. The user assigned the number T mod n is the winner. Print the winner's name. And it also says what is lexicographical order. Like, lexicographical order, simply put in, means the order in which the numbers appear in dictionary. And then there is a formal definition to it. And the idea over here I had was like, because like we need the dictionary order, like we can directly use, if we compare the two number, like strings have an, strings just like integers, string also have a less than sign. And if you do si less than sj, if you do si less than sj, and it will return true only if the ith string comes before j in the dictionary order. And in fact, we can use this to directly sort the numbers to get the dictionary order with us, and like I think there is a concern that all the names are distinct. Yeah, all the names are distinct. There are no same name. Best way to sort in lexicographical order is put them into a string and then directly sort that table. So 1 second. Yeah, STD sort is the best way for this problem. So like 1 second. Yeah. I think yeah, it's synchronous now. So the best way to do it is into put them in vector string A and at last sort A dot begin A dot end, and like this will in fact give us the sorted dictionary order. And at last we print like whatever the index we want to get the required result for us. And essentially that was the solution I had for this problem. And like we also need to take some of ratings of all the people to get the dictionary order we want. So like take every number in dictionary, also take sum of all the ratings, take input, and like also take sum of ratings are modern, at last sort everything and print the r's value. And essentially that's the solution we have. Like for G, like I'm warning, like it's just a heuristic which I ran with some time until 1.75 seconds and just run it, and at last it got an issue. So like not to keep much hope on it, but yeah, like at least I will say something which got an issue there. AtCoder Magics, the Kasi has n cards from the game AtCoder Magics. The ith card will be called card I. Each card has two parameters, strength and the cost. Card I has the strength AI and cost CI. He does not like weak cards, so he will discard them. Specifically, he will repeat the following operation until it can no longer be performed. Choose two cards X and Y such that AX is greater than AY and the CX is less than CY. Discard card 1. It basically says if there is a card with the strength greater, like if you have two cards and the smaller card has more cost than the stronger card, then it's useless because it makes no sense to purchase a weaker card by paying more cost. So it says remove all the weaker cards, and at last you will have some set of cards where like it will be in like the smaller card will have less cost. And it says like we have to print all the index of those cards. So one way to do it is like also note that AI and CN are distinct here. So like one way to do, like n is up to 2e5, had n been up to 100, we would have run an order n square brute force solution comparing each pair of card, and if some card is weaker than any of the card we would have just ignored that card. And because an is up to ne5, we need something smarter. What we can do is like we can first sort all the cards in increasing order of AI values here. Sort in increasing order of AI. Like I might have to probably increasing order of AI. And then like we know that for AI card, all the cards stronger than it would be in the suffix. So all the cards stronger than it would it will be in suffix. So we can keep maintaining the suffix maximum and then realize it. Like we can keep maintaining the suffix maximum, like minimum cost in the suffix, and just compare it with the current value over here. If it's sorted in decreasing order, increasing order, like let the minimum cost here would be some m, then the CI should be less than m, and essentially like that is the condition we have. And that was the idea. And probably let me see if I can do something for this leg here. And essentially that was the solution I had for this problem. And like I can jump onto the code for this one. Like instead of sorting in increasing order, we can also do it in decreasing order, so that we need prefix. And like essentially that's the idea. Take all the numbers as input. First, like I have used a tuple, you can probably use pair or something that works. And then you can probably directly sort the indexes using custom sort, like many ideas are. Like there the first element of the tuple is the value strength of the tuple, second element is its cost, and the third element is its index. Now I sort them in the decreasing order of cost, because like these are sorted in lexicographical order. And then I also maintain like what is the minimum value minimum cost I have encountered so far. So if my current cost is more than the minimum cost I have encountered, I should ignore it, because like it's sorted in increasing order. So like all the I have looked at all the elements which have cost higher than my current element, and if any of them has less cost than my current element, then this element is the weaker element. Otherwise I assign like whatever minimum I have encountered so far as the current cost, and I also put the index of current element in the my final results here. At last I sort all the elements in the increasing order of the index, and I print elements in the increasing order of the index, and essentially that is the solution I had for this problem. Any questions on the first three problem before we move to problem D? So like let me see if I can copy paste. Like D was a bit tricky, and like let me see if I can copy paste this image in my Xcali once, and like that will make a lot easier to explain the problem D. Hmm, 1 second. 1 second. So yeah, problem E says like we have been given as problem D, TLDR. Like problem D, like it says we have some lines, we have some areas, and essentially it says like we have this pattern, and then we have some rectangle coordinates in this part, and like we should find the area of black coordinates in this part, and we should multiply it by 2 and print it essentially. So like let's look at this figure a bit in detail. Like one thing to notice here was like you see like this block keeps repeating over here. This 4 clause 2 block keeps repeating. So what we can do is like first we can count the number of these 4 cross 2 blocks over here. And essentially what I did was like originally our coordinates are like this. like where like this is the origin, but the endpoints can be negative here as well. So first thing to do here was like I did x plus equal to 10 to the power 9 plus 12, y plus equal to 10 to the power 9 plus 12. This is essentially the shifting of origin over here, and like my area will not change, but this allows me to use like prefix some kind of approach where if I want the area of this part, like if I want basically the area of this part, what I can do is like I can find like if this is the origin, I can find the area of all complete this part, subtract these two areas from here. One second, like probably let me just ignore here. Like first I did shifting of origin. Once we have shifted origin, so if let's say we want area of this rectangle, what we can do is like we can find the area of this part starting from origin. Then we can subtract areas of these two parts, the ones in purple, the ones in purple and pink, and then we can add this green area again to get the area of rectangle here. Like this is something we read like the prefix 2D prefix sum, like some people try to do it similarly. So like if we do this way, then our problem basically reduces to one of the endpoint is the origin here, and essentially we need area of something like this starting from the origin. And to find the area of this part, what I essentially did was like I first counted like these 4x2 blocks, the number of 4x2 blocks that would be present here, like the one in the green first. The number of such blocks would be x by 4 into y by 2. So like these number of blocks multiplied by this area over here is 1 2 3 4, like 4 areas, so 4 into 2 8. Like so this is the first thing we should do. And once we are done with this part, if you notice this area, this will essentially cover this complete string, the green part directly, 4 cross 2 number of blocks here. Then if y is odd, then we have to also take into account the area of this part. And you can notice like for each area in this part, like the total cost we need over here is like the total, no, 1 second, yeah. The next thing I did was like first I directly counted the area of this part. X3, no, x is up to 4, right? So yeah. First, then directly count the area of this part. Here you can notice that for each 4 cross 1 block, the area is 1. So next part is 2 into x by 4. And now I am only left with some strips here. Like now I am left with some strips here, like at max 3 such strips would be there. And I can uniquely look at the value of y and try to find the area. Okay, I think, and like, can anyone confirm if everything is fine before I start again once? Hello? Hello, hello, I am back. Like, can anyone confirm everything looks fine? I think I got disconnected once. Hello? Okay, it's fine now. So just give me a second. So like basically I was saying this is the drawing I have with me. And my idea was first, let's say this is the area I want to find the answer for. Yeah, I'm right. I was saying let's say this is the area, like origin starts at, yeah, right. Like this green is the area I want to find the result for. Or probably like this makes a bit better. Then what I did was I first counted 4 cross 2 blocks, the blocks like this. The answer for each of them was same. And like I can directly, this 4 cross 1 block would be covering, would be x by 4 into y by 2 times. So this will essentially cover all the green part here. And then I can first count the area for this strip as well, which is in pink here. Like if y is odd, then this strip also exists. Like 1 second. And the next part was like we will have at max 3 such streams on this side. So like we can first count the answer for two terms, and if y is odd, we may need one extra on the top is there. And essentially like that was the solution. I will jump onto the code once. Four, one, two, three. The problem D it was, right? So like these are the number of P1 is the number of bunches of X coordinate I have, and P2 is the number of jumps of Y coordinate I have. So like initial 4 cross 2 blocks has area of 4. So I directly add 8 into the number of blocks. And if Y is odd, then I also have one strip at the top, which goes up to the next X multiple of X there. And like this is the strip I am talking about. And you see like the area over here is this, 1 second. The area is, this is the area over here. Like one complete here, one here. So overall we have to add 4 into P1. 1 second. This jumps of, yeah, like this is this 2, and like this one was the area. So I can directly add the answer for this strip as well. 2, 1, half, and like 1 second. 1, 2, 3, 4, yes. Yeah. 1 here, half here, half here. So area of 2 is therefore in each strip. So 2 into, like I add 4 into P1. Now I can make X mod 4. I will have at max 4 such sliding jumps at the top on the right side here. Like if you look at this block here completely, like this is the first strip, this is the second strip, this is the third strip, and if you have included 4, it would have already counted. So now we can count like what is the area for each block over here. So for example, if y is even, then this would be the area, and if y is odd, we should add 1 for this as well. So if x, and similarly for the second strip you can add an if, and third strip you can add an if, and that would essentially give you the solution. So if there is at least one extra strip, then you add the area for the first strip. If there are at least 2 strips, you also add the area for the second strip. If there is at least third strip, you also add the area for the third strip. And essentially that was the solution. Shifting of origin was like basically adding 10 to the power 9 plus 12 at each coordinate over there. and like get AB like the complete area from origin, complete smaller rectangle minus ABCD, and essentially this was the solution. Any questions on this one before we move to the next problem? Any questions on this one? Like it was slightly tricky and like might not be easy to get out. So I will move to next problem then. It says remove pairs. Takashi and Oki are playing a game using N cards. The front side of the card has AI written on it and back side has BI written on it. Initially N cards are laid on the table. The Takashi goes first. The two players take turns performing the following operation. Choose a pair of cards from the table such that either the number of their front side are same or the number on their back side are same. Remove these two cards from the table. If no such pair exists, the player cannot perform the operation. The player who is first to unable to perform the operation loses. The other player wins. Determine who wins if both play optimally. So like we have some set of cards, and like we have been asked like we at a time we will pick two cards which have same value on the front side or the back side. Essentially, if you look at it, like you can create an edge from I to J for each pair of cards which have same pair of cells, and you can pick one edge from the two sides and everything splits up there. And like fortunately or unfortunately, the n was up to 18 over here, and like it asks us to print who is the winner. So the idea was to use the minimax algorithm. The idea is like we have some set of cards which still remains, and the player to move looks at all the possible pairs he can pick up, and he tries to see like can the other player win by the remaining moves over here. And the solution was mostly to brute force with memorization for what all the set of cards that can remain, which was up to 2 to the power 18. Which says like we have a mask is the remaining set of cards. If we have already computed the answer for mask, return whatever value we have. Otherwise, iterate on all the cards which are still on the table. And if they have same value on the upside, top side, then see like who would be the winner if we remove these two cards. If the next player to start loses, then the current player can directly play that move and wins. Otherwise, like the current player does not have any move which can force the other player to win. Or the other way to say is like whatever the current player plays, the other player definitely has some moves to start with to play over here. And at last, we can see like does the first player win or the second player. If first player wins, we print Takashi. Otherwise, we print OK. So any questions on this one? And like there is one question on the chat. Can E be somehow related to connected component? I somehow thought along those lines but could not come up with the solution. I'm not sure like something you can do directly by looking at the connected components there or the number of nodes in a connected component, nothing like that. But one thing I would say is like it's definitely possible to solve this problem for n equal to 1000. And the idea would be like for each pair of nodes we will create an edge if both of them can be taken together. No, I am not sure. Like I vaguely remember one game theory problem where we find the maximum matching over here. And like the idea there was like on each matching, if there is a perfect matching there, then for each card there would be the other player to pick it up. But that's not possible for this case. So like not that was a false statement. Like it's like and essentially this is the solution. Like it's not possible to solve for n equal to 1000, but for n equal to 18, you can use the minimax algorithm in the game theory and continue doing the part. Any questions on the problem E? Okay, I will move to problem F then, and like useless LIS. Like you can probably use mask or you can use memorization where you have a vector. Then you will have to maintain like basically mask is to denote like what all cells are remaining there. Either you can maintain a vector, and then where in vector you have all the indexes which still remains there, and then you delete values from the vector. You can also use a set there. Then you can use set dot erase and find the answer. Like mask is easier because that's just one integer. So you can in fact instead of maintaining a map or something, you can directly maintain the total length of all the possible marks. How does this algorithm make sure that I will always win? So like, let's look at it like this. I am the current player to play. I look at all the possible pairs I can pick it up. And for each pair I see, like, can the other player now win? Okay, like, I have some set of cards and I have a function which returns like, can the, if these are the number of cards remaining, can the first player to start win now? Make sense? Like, at the end of the day, we will put all the values as input to this function and see like, can the first player wins. If first player wins, we will print whoever was playing first, otherwise we will print whoever is playing second. Now to solve this function, I have a set of cards. I look at all the possible pair of two cards I can pick it up, and for each pair I see like, if I remove it and I call the same function, who is going to win, either the first player or the second player. If there exists a move which says like, if you remove these two cards now, then who is going to play next can no longer win, then like, this should be the move I should play over here, because now the second player has some set of moves, but whatever he plays, he is definitely going to lose by doing brute force or whatever I am finding here. And if I do not have any such move where I can force the next player to lose, then I would be the one I would be losing, because it doesn't matter what I play now, the other player who is going to start now is definitely going to lose there. And like, that is essentially the minimax algorithm in the game theory there. Like, I am the one who is going to play. I look at all the possible choices I have and I see like, if I play this, can I ensure that the other player who is going to start is lose? If I have such a move, then I say I will definitely play that move and I will lose. Otherwise, the other way to say is like, irrespective of whatever I play, the second player will have something that will ensure that he or she wins. And like, that is how this algorithm works over here. And like, the condition to ensure like, you won't have like, because we are keep removing the card, there won't be the case that we have the same set of cards again, because at last either we will have 1, 2, 3 whatever cards with no possible moves, and whoever is going to start now will definitely lose. The next problem says, useless for li, you are given an integer sequence a of length n. For each t from 1 to n, determine whether it is included in the longest increasing sequence of a. Here it is included in longest sequence if some definition is given. Basically what the problem statement says to us is, like, we have some cards a1, a2, a3 up to an. Let's say we have t equal to 3. It says like, first we have to find the longest increasing sequence length for the complete array. Let's say lis is 5. Then it says like, does there exist a sequence, increasing sequence of these cards such that a3 is definitely there in that sequence? Like, basically, like, there can be multiple lis of the same length, and my idea was, since a3 is definitely there in the sequence, what I can do is, I can do greedy part. I can first find the longest increasing sequence in this part, which ends at I equal to 3, and I also find like the longest decreasing sequence in this part, or probably like, other way to say is longest increasing sequence here, which starts at I equal to 3. So if overall like total lis is 5, then my claim is like, if I get x elements from this lis and y elements from this element, then if I combine both of these lis, total number of elements I would have is x plus y minus 1, because 3 is counted twice. Like, I will probably use mouse for timing. My idea was like we have this sequence A1 to N. We want to see like does A3 exist in the one of the possible LIS. So let's say like the longest possible length of LIS for the complete array is 5. Then I look at first the length of longest increasing sequence which ends at 3 in the prefix of this part. And I also look at longest increasing length which starts at 3 in the suffix part. So the idea is like maximum possible length LIS, maximum possible increasing sequence, which also includes element 3, would be the one for the starting part which will end at 3, and for the remaining part which will start at 3. So I can combine these two sequences. So like the total possible overall length I can get, which must include the element 3, would be the sum of both minus 1 because both of them count 3 twice. And if this is equal to 5, then I claim that there exists one LIS which contains element 3. If this is less than 5, I say like there does not exist an LIS where 3 exists. It cannot be more than 5 because I initially claimed that 5 is the maximum possible length I can get for the complete array. And like then there was other way, like I can either increase LIS and that which ends at I equal to one part and which ends starts at other part using two different functions. Or the other way to do it was like I write one function which counts for each index, like what is the maximum length which starts at it. Then like for computing the other part, well, LIS which starts at some index, what I did was I reverted the sequence and now I want to count the longest decreasing sequence over there. And what I can do is I can even multiply all the elements by -1, so that instead of LDS I only need LIS over there. And like that was essentially the part of it. So like I can essentially use the same function to do other with some manipulations in the input part, and then I can revert back to do whatever I want. And essentially that was the solution for this problem. So and to find the LIS which ends at some index, I can use the segment tree approach to calculate LIS there, which would be like first I do a coordinate compression of all the indexes. Like I have this vector and it returns like for each it returns a vector of size n, where the ith element is the length of LIS which ends at that index over there. And now my segment tree, like this is coordinate compression part for it. And now I do like y dot, I basically find the compressed coordinate for the current element, and then I look at like what is the element which ends at some index for a particular element from 0 to y-1, because it says strictly increasing. So I include that as to the current response, and then like I update the value again. I think this is not required, but whatever be the case, like I can directly set g as the value here and response there. So like I first take the forward part which says for each index I need the starting part. Then I reverse the array. I multiply all the elements by -1. So now you see like reverted array, we need the longest decreasing sequence which adds at some index. And if you multiply each element by -1, we need like again the increasing sequence which ends at some index. And then I reverted the same list again. Then I also found the maximum possible length, which would be like for I can take for maximum element from forward, backward, anything works. And to get the response, I look at all the elements. This is the number of the maximum possible increasing sequence length, which adds at index I. Maximum possible increasing sequence length which adds at index I. -1 should be here, which should be equal to LIS. If that's the case, I should add it to the answer and at last print everything in the answer. Like we can use binary search for that. Not sure like what binary search we need over here. Like it would be great if you can probably add it in the comment section. So essentially this was the solution for problem F. Like problem G, I will probably say like what heuristic or what random thing I did, I got an AC. But yeah, like at least I don't have any proof why it should run within, similar to finding LIS in n log and using binary search. Okay. So like I can share what I did. I don't have any proof why this simple solution should get an AC and what should be the solution there. But yeah, let's get started. First I did was like, I will also include my summary. First thing I did was like I made all the input strings unique by removing any element. Like for example, there are strings to like, if there is two string coder, one of them has the value 3 and one of them has the value 5. So it makes no sense to keep the coder with value 3. So just delete it. So like that was the first thing I did. Like this is the part for it. Read everything. Create a map with maximum value for each cost. Clear it, keep it, and change the size again. Now the next thing I did was like for each element create an adjacency list. Like which all indexes are in its subsequence and which are for which all indexes it would be in subsequence. For that I ended up using hashing over here, and like this is essentially the method for I equal to j to n something. If I is the substring of j, in the adjacency list of e push j, and in the reward of the adjacency list for j put I. And for checking if it's the substring, I use hashing substring interval hashing there. Essentially like for each first element length is n, for second element length is m. So for hash of check hash of each substring of length m, if it matches to the other string, return true. This is the substring, otherwise it's not. So like so far good. Like some people would have realized by now, like in this graph of e, what I essentially need is maximum weighted click or maximum weighted independent set. And like if you look at the independent set or maximum weighted independent set, it's NP hard problem. Like one good thing or in this graph is like if we have some vertex, let's say 2, like 1 is the substring of 2 and 2 is the substring of 3, then it is definitely the case that 1 is also a substring of 3. So like that was something gives us like it's not explicitly calculating the maximum independent set here. Like we can have some conditions there. If you look at the complete graph, it would be like there are some roots node at the top where like which are not the substring of any node. Then there would be some nodes, there would be some more nodes, and essentially. So like the first greedy algorithm I did was keep trying, and like in the increasing length for each node, if it's present in like I am maintaining a Boolean vector, what all elements I want in my current set. If I have already picked any parent of it, then I am going to ignore this case. Otherwise, I see like among like now my current string is something which I have not taken, and like there can be some substrings which I have already taken. So I greedily check, does it makes any sense to remove all the substrings of this string and take this string? Will it increase my answer? If the answer is yes, I will do this flip. Otherwise, I won't do this flip. So delta is like if I take the current element and if I remove the cost of all the elements which are substring of this and I have already taken. And if this gives negative, then it does not make sense to delete all the substrings which I have already taken and take the current string. Otherwise, I take this current string, I marked it as true, and I remove all the substrings from my current set. And like I kept doing this until I finally got a graph where like I can no longer remove some substring set to get a parent set. So I added the cost of all the elements and I printed the answer. This just worked for 14 test cases and there were 34 WS. And one reason why this fails is like I can give you a counter example. So like let's say we have this string A, B, and we have CAB and CBA. Let's say this element's cost is 8. This element's cost is 8. 12. Okay, we have these strings where we have A of cost 8, B of cost 8, we have CAB of cost 12, CBA of cost 12. Now, if you look at individually for this string, it does not make sense to remove A and B to get an element of cost CAB of 12. Similarly, if you look at CBA, it does not make sense to remove this 8, 8 and get a 12. But if you look at in the longer run, you can remove this A and B to get C and B of total cost 24. And like my current algorithm will give me 16. So the next thing I did was like, instead of looking at in the increasing sequence of element, I just ran 1000, 10,000 random, 10,000 possible permutation, and I iterated in this order. Like right now it was directly in I2N, and like it always gives me the same configuration. So what I can do is like I can do random shuffle. I can try out multiple permutations doing random shuffling, random order of shuffling over here. So that was the next bit I did. Try around 10,000 shuffles, randomly shuffle the permutation, and do the same thing. Like now in this random shuffled order, for this string, looks, does it make sense to remove this string and take all, like take remove all of these substring and take the current string over here, and then at last whatever present, add that to the sum, and whatever maximum I got printed. Again, this was W, but this time only 8 test cases failed, 40 of them passed. So now the next thing I did was, instead of doing 10,000 shuffles, keep doing it until the total time, like 2 seconds was the time limit. So keep running this algorithm until it like the number of iterations I run is 1.9 seconds, and essentially pretty much. And this ended up getting the remaining aces there. And like to count the time, you can probably use the standard library method, which I had in my config. So not something which you would like to see, but like this was something which I ended up doing, and like it passed. So yeah, any questions, anything else other there? Like not sure why internet connection was a bit slower today, and like that ended up wasting some time. Yeah. Any questions or any other questions before we call it a day today? So I think I will end the stream now. Thanks everyone for joining today. सर गेम थ्योरी कैसे improve करूं? Like yeah, like I have one algorithm. Like there was one moderator on Codes of Discuss who goes by name Viju123. Not sure why it says this no longer is active, but he written a one very detailed editorial there. So like you can probably try to look at it, like at least the game theory problems which we get in AtCoder ISIN for the last three problems are mostly brute forces. So like I will probably search for some problems and put it in the comment there. Like probably check back by tomorrow evening once. So like there was one detailed editorial by Viju. He wrote it for some one of the ICPC reasons, and like that was one of the go-to editorials for someone to start with. So I will put that link in the comment section by tomorrow morning. And then the other ways to do is like probably to look at CP algorithm problem. Like at least this min-max algorithm is something you should know, and like it has appeared frequently in ABC, and that is one. And probably like you can probably look at CP algorithm and use our guide and CP handbook once, and like that theory there should be sufficient for now to solve ABC problems, but might not be easy to solve some more tricky part, but at least it will give you an idea how to think about it, and that's important here. So any more questions? Yeah, probably I will put it in the Discord as well, like on the general channel there. So that was one question. Any more questions? So thanks a lot for joining today. And yeah, I will end the stream now.